Okay, good evening. Let's start the class. Sorry for the delay. We got a bit late to start the class, and then after connecting this, there was a small issue with connecting the mic. I was checking this, and now all is fixed. So can you send me a message mentioning whether the even I can check how's the sound and all, whether it is clear? Can you send me a message, everyone? Okay, all good. Okay, so here we are starting this in the class. I was just mocking about this with the name makeup class, but then late I thought of a good name, which is the cover up class. So we are doing this, we started. So I'll give you a brief explanation here. So what are we doing here? Brief, 1 second. We have the no polynomial functions as we have it. So I'll give you a brief idea about what are we doing here. Yeah. I'll just send the tut in the Telegram group. It's basically the same one. The same tut that you have been given in the class. This polynomials. Let me see. Okay, it's polynomials. Okay, so we have uploaded the tut in the Telegram group again, once again. In the Telegram group once again, clear. Okay, no, it's not the basic algebra tut. No, it's the polynomial tut here. And for the newcomers, in the physical students who have been attending the physical class, for the newcomers, we have given the tuts for them. So far in our class, there are 3 tuts. The first one is the basic algebra tut. The second one is the polynomials tut, and the third one is the trigonometry tut, which probably by now everyone should have received it. Yeah, so we are okay to start. So just one more thing about this class. So what are we doing here? To give you a quick idea, we started classes in March. Okay, so the sound actually all good. Okay, sound is good and all is good. So we started the class in March. We started the class in March, and then in March, I'll write it here. So in the 2028 English medium class in March, we have done this lesson, basic mathematical concepts. Okay, we have done basic maths concepts. We have done basic math concepts. Okay, and then in April, we did There's a small lesson called numbers. A small lesson, numbers, and then we did inequalities. Numbers and inequalities. In May, we started the first main lesson. I'll tell you why am I telling that this is a main lesson. Polynomials. We started this one, polynomials. In May and in May, June. So we took around 5 weeks to do this. So May, June, we have done this. And then again in June, we have done partial fractions, a 2-week lesson. Partial fractions. And then in July, so this is the August. So in July, we have done modulus functions. So we have done modulus functions. Okay, modulus functions. So here, I told you these recordings, the lessons that we have done. The lessons we have done in March and April are available in YouTube. So we have published them in YouTube as public videos. So anyone can access them. Not unlisted one. We have uploaded them as YouTube public videos and anyone can access them. And even we have uploaded them to the group. So if you can't find them in the YouTube channel, you can easily, when you go to our YouTube channel and when you go to this playlist, you can easily find this. But let's say in case you won't be able to find this, it's a bit too close. You are not able to find this. If you're not able to find this in the in YouTube, you can find them in both the groups. We have uploaded this in the WhatsApp channel and even in the Telegram group. Okay, and then these recordings. So this is what I'm going to do through this makeup class, the cover up class. Let's use the word cover up class. We will be doing these 2 lessons mainly because I'll tell you the reason I'm doing these lessons. Polynomials. So this is the lesson that we are starting today, and modulus functions. So why modulus functions or modulus graph? So why am I doing these 2 lessons in this class? Because in these 2 lessons we have past paper questions. So that is the reason I told you this is the first important lesson we started. These lessons are not tested in in A levels. In the A level paper, these lessons are not tested, but in the syllabus we have to do that. And in the first papers of our paper class in your school first term test, probably there will be there will be questions related to this regarding numbers and inequalities. Okay, related numbers and inequalities. Clear? So then in this one, so that's the reason I'm doing this again as a live class, because there are some students who are okay with watching recordings. By now even they have watched some of these recordings, but there are some students who are not okay with recordings. In that case, they want to join a live class, because what the students are telling us, like say if you do the live class in 2 hours, we can join it and get it covered. But if I'm supposed to watch a 2-hour recording, probably I'll be taking more than 4 hours, 5 hours to watch that recording. So because of that reason, it's always good to do these live classes. So through this one, the cover up class, I'll be doing the polynomials and modulus functions. And again, I think this one we haven't uploaded yet, but I'll ask the admins to even upload this, because this is not a main lesson that is directly tested in A levels, but inside different lessons. For example, in series, in integration, we have to have this knowledge of partial fractions. It's not a direct question, but it comes with connection with another one. So even here, I think already we have uploaded the YouTube recordings. If not, I'll ask the admins to upload them too. So then through this class, we will be doing these 2 lessons and we will be covering all the past paper questions. And the other main thing is this class is not a class that where we are revising the theories. I'm doing it in the same way that I have done these lessons in the theory class. So in the theory class, we did polynomials for 5 days. So 5 days means the class, the theory class is from 3 to 7. So let's say excluding the interval, it's like 3 hours and 45 minutes. And let's say that if you take out the time that we give for to have a small chat and the time period given to solve problems inside the classroom, let's say it's a three hour and 3.5 hours recording or a class. So here I'm doing this in two hour recording. So today it's like only 1.5 hours, but because we started a bit late and I'm doing this introductory session. So we will be doing this in 2 hour sessions. And like if we have done this in the physical class, okay, for 5 days of 3.5 hours, probably in this online class, we are using 2 hour time slot. It will go around 6 to 7 days. Okay, so in 6 to 7 days. So that's I told you, this is not just revising the lesson. Okay, I'll be giving the exact note and we will be doing the exact number of questions that we have done in the normal 2028 theory class. Okay, the physical class, which is even streamed online, where online students like the online students are joining the class live. So then I'll be doing these two lessons. So then you can cover them. And my thing is this basic mathematical concepts that there are 4 days. Okay, here we have 4 days. For recordings, numbers is one recording, inequalities is two, and partial fractions is even two. You don't have to worry about these two because anyways we will be doing this. No, so you don't have to watch, being honest, you don't have to watch these all basic mathematical concepts recordings. But if you feel like if you're a student who have attended a previous maths class and your simplification, these expansions, this the working with square roots are fine, if they are okay, then you don't have to worry about watching these recordings. But if you're a student who find these simplifications a bit hard, when you take these numerator denominator simplifications, root simplifications, if you find it a bit hard, then you can watch these, because in this one we have explained how to solve simultaneous equations, how to simplify root values, then how to do fractional simplification. So we have done this in this way. Clear? Okay. Okay, so then I think that all is good. So this is what we have to do. So we'll be starting today with polynomials. And as I mentioned, this will be an exact replica of how I have done the theory class. But the thing, the note might be slightly different, because when I'm teaching, I don't bring any materials to the class. I'm not giving a note that which have been written already. I am giving the note at that moment, which is in my brain, which is in my memory. So it is not the exact note. There might be slightly differences, but the concepts and theories and the problems and the approaches that we have done for a problem will remain the same. But there might be small, slight differences with some of the terms. Okay, and this one is important. This one is good for the students who have attended our class even previously, but while doing polynomials, they didn't have a proper idea about A levels and all. They didn't have a proper idea about what is this A levels, how to work in this one. Because of that, if they find this polynomials lesson hard, if they want to revise this lesson, for the students who have been attending our class, even when we were doing polynomials, can watch this and you can get this done. Clear? Okay, so that means we will be doing this for let's say for like 2.5 months, polynomials, let's say 7 days, and modulus functions like 3 days. So we'll be doing it for like 2.5 months. By then, you have to cover like this one, partial fractions that you need to cover. And these two, inequalities is something important, but basic mathematical concepts I told you, based on your mathematical simplification knowledge and ability, you can decide whether you want to watch this or not. Clear? So we can proceed. Okay. So then write the topic. Don't write this in the trigonometry book. Keep a separate book for trigonometry. Keep a separate. Okay. All good and all clear. Right. Good. Okay. So then I was mentioning, don't use the trigonometry book. Keep the trigonometry book separately. And then like let's start from this one. Take a new book, or if you have any other book that you have used in a previous class or any other book, you can use that. Okay. Then write the main topic, polynomials. Write the topic, polynomials. Right, the main topic, polynomials. Okay. Okay, so first thing, before talking about polynomials, can everyone send me a message mentioning that you understood it and all is good, all fine? Everyone send me a message, please. You got idea and you know what are you supposed to do. Clear, no? All clear, good. Okay, so I need everyone to respond and keep even like similar to the normal theory class where your Zoom chat is active and then the chat is engaging. So even I can actively participate in the class and actively communicate with you all. I need you to keep this chat active related to academic stuff. Okay, when I ask you a question, you can answer because this is entirely online class. No, I can't see there are no any students where I can see answers. So only response that I see is the chat. So I need answers from you all. If it is a physical class where we are streaming the class online, then it's fine because anyways we have in physical students who are answering, but this is a completely online class. Okay, then write the main topic, polynomials. Okay, so before talking about polynomials, we need to know what is a function. So function is a separate lesson in the syllabus, which we will be doing after trigonometry. After trigonometry, it will be a separate lesson that we are doing, functions. So I'll just give you a basic idea about what are functions before starting polynomials. So we can say a function is a mathematical relation, which consists of variables. Okay, or a relation or an equation. So here, normally a function is denoted by this fx. So f is not because it is function for f. Normally that is how we denote it. Even you can use any letter, gx can be used. You can't say that f denotes function because but that is how we used to do that. When it is a function, we say it's f. So for example, if I say think of a velocity, we mark that velocity as v based on the word velocity starts with v. Not that you can't take any other letter, you can take any letter. You can take u or any letter. Even here, normally we are denoting it by fx, but you can use gx, any other letter px. So here, what is a function? A function is a mathematical relation consisting in variables. So here I'm writing 1x plus 1 is a function. So we have fx is equal to x cube plus x square minus 2x minus 7. And if I write another one, let's say gx, we have 2x to the power 5 minus 4x cube plus 7x square. So this is another one. So we can use different letters, x cube plus 1 over x minus x to the power minus 2 minus 5. And even there might be functions consisting 2 or more variables too. So let's say if we have x squared y minus xy cube 7y squared like this. So here when you have two variables, we denote it as x and y. So these are functions. What are functions? Functions are mathematical relations consisting of or equations consisting of variables. And normally we denote it by f, but it can be any other letter, fx. This x is the variable. This denotes the function. So in this case, g denotes the function, x denotes the variable. That's case this here we have two variables, and here we have the function. Okay, write in this way. Write in this way. Write in this way. A mathematical relation. So relation is like in maths. I mentioned that in the class in maths, a relationship is known as a relation. Okay, not these like we call cousins. All these cousins are relations, not those relations. Like normally a word that we can use to denote a mathematical relationship is a relation. Okay, so we can say that that is a equation. Same idea, not the exact same idea, but you can have the same sense. Okay, a mathematical relation consisting of variables consist in variables are known as functions. Are known as functions. Okay, write these functions down. Again, when I ask you to write down something on the board, so when you have done, just send me a message. The same thing which I just mentioned, because I can see if it is a physical class, we have students here, so I can see whether they have done writing or not. But in this case, I need your help. Okay, good. So here now, like first we discuss what are functions. So we know a function is a mathematical relation. And now if you be specific about polynomials, polynomials are functions that consist of the positive integral powers of the variable. A polynomial is a function that consists of only the positive integral powers of the variables, and there can be constants. So here, if you look at this is x to the power 1, which is a positive integer. Okay, it's a positive integer. And here all these are positive integers, and I told you there can be constants. Not that having a constant is a must, there can be constants. So all these are only having positive integral powers of the variable. Even this one is the same. We have positive integral powers of the variable, but in this case, it's clear we have a negative integer. We have a negative integer which do not fall to the definition of a polynomial. So then these functions are, these are polynomials. These functions are polynomials because they only consist of the positive integral. I'll write it polynomial functions, positive integral powers of the variable and constants. But if you have a negative integral power, that is not a polynomial. So this is not a polynomial. So even this is a polynomial because a polynomial can consist of several variables. That doesn't affect of being a polynomial. Only thing that it should be like under the definition. What is the definition? A polynomial function is a function that only consists with positive integral powers of the variable, and like there can be constants. Constants can be seen. Okay, so here both these are wrong because this is even x to the power minus 1, which is a minus power. This is minus 2. Okay, then write in this way after writing these examples, write in this way. So this is even a polynomial, not that only these are polynomials. Write in this way, put a red star mark and write in a normal pen. Put a red star mark and write in a normal pen. Write this. A function only consisting of a function only consisting of positive integral powers of the variable, positive integral powers of the variable positive integral powers of the variable and constants and constants and constants. Did I start with a function? No, singular. No. Okay, and constants is known as a polynomial function. Write the word polynomial function using a red pen. Is known as a polynomial function. Is known as a polynomial function. Okay. Okay. Then you don't have to write them again. So here you can just show that this is a polynomial, this is not a polynomial, and this is a polynomial. You don't have to write this again. No need of writing this again. Okay, so we can write this. These are polynomial functions, not a polynomial. This is a polynomial. Okay, so a polynomial can consist of two or more variables too, but normally in our syllabus, we are working with polynomials only consisting of one variable. That is in our syllabus. Okay, in our syllabus, we won't be working with polynomials where it consists of more than two polynomials. Okay, okay. Then write it this way. Degree, a subtopic, degree of a degree of a polynomial. The degree of a polynomial. Okay. So what do we consider as the degree of a polynomial? So these are simple ideas. These are simple ideas. You might be thinking these are complex concepts based on the base of my voice. Okay, because I know that my voice is having a natural base. So based on the base of my voice, you might be thinking when I just talk about some of the definitions of maths, you might be thinking these sounds like complex concepts, but no, these are really easy concepts. Don't judge the concept, the complexity of the concept based on the base of my voice. Okay, okay. Because the thing is, I used to be in the media unit at school, so I have done announcing and all. So my voice is naturally built up for that. Not naturally, we have trained that for that purpose, not having that much of bass like which sounds like a TV commercial. But I know naturally there is even though I try to control it and I like it. Being honest, I really like my voice. I don't know why, but I like my voice. Okay, so these are simple concepts. Then write in this way, what is the degree? I'll explain what is the degree of a polynomial. A degree is the highest power of the polynomial. So here if we have fx is equal to 2x to the power 4 plus 3x cube minus 7x square plus 1. So here it's clear the highest power is 4. The highest power is 4. So the highest power of a polynomial is considered as the degree. The highest power of a polynomial is considered as the degree of the polynomial. And then the term consists in that degree. The term consists in the degree is known as the leading term. So it's like he's like the lead of the polynomial, leading term. And the coefficient of the leading term is known as the leading coefficient. So these are simple meanings, simple ideas, just words that you need to know. The coefficient of the leading term, coefficient of the leading term is known as the leading coefficient. Okay, so what is the degree? A degree is the highest power of a polynomial, and the term consisting the degree is the leading term, and the coefficient of the leading term is the leading coefficient. And the other thing is, normally we categorize the polynomial based on its degree. The polynomial is categorized based on its degree. So this is a fourth degree polynomial. So there are third degree polynomials, first degree polynomial, second degree polynomial. So we categorize polynomials based on their degree. Let's say the highest power is 10, the degree is 10. So we can call it as a 10th degree polynomial, similar to the grade. Is a 8th grade student, is a 7th grade, is a 10th grade student. Okay, we can write it this way: the highest power of a polynomial the highest power of a polynomial highest degree of a polynomial is known as the, write in a red pen, degree. Is known as the write in a red pen, degree, then normal pen. Only the word degree by red pen is known as the degree of the polynomial. Degree of the polynomial degree of the polynomial. Okay. The next line, the term consisting of the degree, the term consisting of the degree, the term consisting of the degree is known as the, write in a black pen, leading term. Is known as the, write in a black pen, leading term. Leading term is known as the leading term. Okay, same line. So when I say to switch the pen, make sure that you write the word that only we need to highlight using that pen. So when I say write in a black pen, that's only leading term, because I can't keep telling, okay, now normal pen, black pen, red pen, normal pen. Okay. Okay, then the coefficient of the leading term, the coefficient of the leading term, the coefficient of the leading term is known as the, is known as the, is known as the, write in a black pen again, leading coefficient. Leading coefficient. Okay, okay, then write this one. Okay. Okay, then I told you we use this degree to call the polynomial or categorize the polynomial. Okay, then after this put a normal star mark and write polynomials are categorized. Polynomials are categorized polynomials are categorized based on their degrees. Based on their degrees. Based on their degrees. Okay. And then just write as example, write it this way. So just put a dash. First degree polynomial. First degree polynomial. And then third degree polynomial. We just categorize them in that way. Okay. Okay, then use in a black pen write note. In front of that, use in a red pen write. So write a note. So when I say write a note, now you know the normal way we write notes. No, so I don't have to keep mentioning. Even in the physical class, I won't be mentioning. Write note in a black pen and the next one in a red pen. We don't have to do that. We can just write it. When I say note, write the note in black pen and the note or the topic that I'm giving in a red pen. Okay. Write this. General polynomials. General polynomials. General polynomials. General polynomials. With a given degree. No, general polynomials when the degree is given. General polynomials when the degree is given. Okay, so here what we do now, when we know the polynomial with the degree of the polynomial, how to write the general polynomial. So this is what we are going to discuss here. How to write the general polynomial. So this is what we do. Okay, so this is what we do. Now look at this. If we say I'll start with degree 1, well, let's say first degree. So when it is the first degree, there should be x term. So there should be a x term for sure. And now look at this, I'm asking a question. I'm asking what can you say about the degrees of these three polynomials? We have x, we have 2x, we have 7x minus 1. So what can you say about the degrees of these three polynomials? So let's say this is fx, fx, fx. Tell me what can you say about the degrees of these three polynomials? The degrees are the same and all other degrees the 1. Which means now it is clear in all these polynomials, the degree is 1. So we know the mandatory term that should be there to be a first degree is x. And even, okay, and even this one, the coefficient can change. It can be 1, 2, or any coefficient. So then x is the mandatory term that should be in a first degree polynomial, and the coefficient can change. So I'm writing a in general, I'm writing a a. I'm writing a a. Let's say we are writing a. So let's go with the simple letters. And then it's clear there can be a constant. There can be a constant, but having a constant is not a compulsory requirement. There can be a constant because there can be, I'm just writing it as ax plus b. So now it is clear when I refer to the degree is not 0. The degree is not 0. Here, look at the degree. Degree is the highest power. Here, it's the first power. Now, when you have x, it's x to the power 1. X is x to the power 1. So the degree is not 0. It's 1. It's not 0. Okay, so here it's ax plus b. And now when you have the second degree, so then what is the mandatory term? It should be, there should be x squared. There should be x squared. And then the coefficient can change as I discussed. So we have a x squared. And then there can be x terms and constants, not compulsory terms. So then we have this bx plus c. Bx plus c. Okay. So which means when you have the degree, that should be the highest power. And then we write the other terms which are having a less power than the degree. So these are not compulsory terms. Like if I write these now tell me in these examples, now tell me how much is the degree? Tell me. What can you say about the degree of these 4 polynomials? Yeah, wait, I'll come to this degree 0. I'll come to that point. A good point. I'll be talking that after writing all these. Tell me, what can you say the degrees about all these 4 polynomials? All 4 polynomials, what can you say? Clear the degree is 2. No? The degree is 2. The degree is 2. So that's why I told you the x squared is only the compulsory term. These terms can be there, but not a compulsory requirement. Okay, so here now it's clear if I write the third degree polynomial, you should have a ax cube, a bx squared, cx plus d. And if I write the next one, the fourth degree polynomial, we have ax to the power 4, bx cube, cx squared plus dx plus e. Clear? So this is the compulsory term that should be there. Okay. So this is the compulsory term. Other terms can exist, but not needed for sure. Okay. So this is the compulsory term. Okay. Now it's clear the one that a student asked the question. So here if I talk about a 0 degree polynomial, if I talk about a 0 degree polynomial, okay, and then it's like ax to the power 0. But we know x to the power 0 is 1. X to the power 0 is 1, which means we say a 0 degree polynomial is a, which is a constant. Okay, a 0 degree polynomial is a constant. And here this is even correct, like we don't write it, so that's why we just miss it. Here you can write it as 0th degree. Okay, there's a word called 0th degree. 0th degree, if you write this 0, there's a word as 0th degree. The thing is that we don't write it. No? The thing is that we don't write it, that's why. But there is a word, 0th degree polynomial. Okay, 0 degree polynomial. Okay, then write this in this way. Just put a note and then write. So after this note thing, write in this way. Write in this way. The general polynomial okay, the general polynomial can be written in the following manner. Can be written in the following manner. Can be written in the following manner. When the degree is known. When the degree is known. When the degree is known. Okay, okay, then write these down. So yesterday, how to balance both sports and studies question. Yesterday, what did we do? Yesterday we had I think day before yesterday, no? Yeah, I think you asked this question. You asked this question during the revision class on Monday, I guess. Yeah. No, I'll talk about this in a theory class. So not that I'm promising that I'll be talking about this in Monday, but when it comes, like there are certain ways that some of the topics come. So when we talk about this mental health and all, out of nowhere, I can't just talk about mental health. There should be a reason why we need to talk about it. The reason pop-ups, not not pre not prepared before, like reasons pop up in that way, but I'll make sure somehow within let's say in 2-3 weeks in the normal theory class I'll talk about this. Done? No? Okay, good. Then write the topic. Then write the topic. Write the topic. equality of two polynomials. Write the topic. So this is the main part that we will be doing today. Equality of two polynomials. Write the topic. Equality of two polynomials. Okay, so now let's say two given polynomials are equal. So I told you, okay, I told you in this, how do we categorize a polynomial? A polynomial is categorized based on its degree. No? So it's like the weight class of the polynomial. You know, when we are talking about this martial arts, the sports, and where fighting is in like fighting is there, like let's say karate, boxing, wrestling, judo, taekwondo, in these and even wushu. I'm not sure about wushu, but in other martial arts, when it comes to this Olympic level or like international and national level sports, there are weight classes. Because, for example, a 60 kilogram weighing boxer can't fight with a 120 kilogram weighing boxer. So it's unfair. So he is getting an added advantage from its weight. Okay, so then we know that we are having those competitions in weight classes 60, 65. In wrestling and boxing, we have featherweight, then heavyweight, light heavyweight, light featherweight, and then there are a few other weight categories. So same thing when it comes to polynomials. If I want to talk about the equality or the similarity of two polynomials, it should be in the same category. It should be in the same category. So then I mentioned, how do we categorize a polynomial? A polynomial is categorized, okay, based on its degree. So now if we have two polynomials are equal, if fx is equal to gx, then they should be having the same degree. That is the first requirement. Both fx and gx are having the same degree because they should be in the same category. The first thing, there are 2 points like we'll be talking about. The first thing that should be satisfied to be, if two polynomials are supposed to be equal, in the equality of polynomials is that two polynomials should have the same degree. Clear, the two polynomials should have the same degree. And now, so let's say two polynomials fx. I'm writing two second degree polynomials bx plus c, and gx is equal to px square plus qx plus r. So this one, both are same, having the same degree. So even here the degree is 1, 2. Here the degree is even 2. So we have the same degree. Okay, we have in the same degree. So now, if fx and gx are equal, the other requirement is, so these two are equal. Fx and gx are equal. If fx and gx are equal, the other requirement is that the corresponding coefficients should be equal. So what do we mean by corresponding coefficients? The x squared coefficient of both the polynomials should be equal. The x coefficient should be equal. The constant should be equal. So we say the corresponding coefficients are equal. So in this case, a is equal to b, a is equal to p, sorry, b is equal to q, and c, the two constants are equal. So corresponding coefficients are equal. So this is corresponding coefficients are equal. Corresponding coefficients are equal. Clear? Corresponding coefficients are equal. Okay. Okay, write it this way. Write it this way. If two polynomials are equal, if two polynomials are equal, if two polynomials are equal, the following two conditions are satisfied. The following two conditions are satisfied. The following two conditions are satisfied. First one, the degrees of the polynomial should be equal. The degrees of the polynomial should be equal. Should be equal. Second one, the corresponding coefficients should be equal. The corresponding coefficients are equal. The corresponding coefficients are equal. Okay. Okay. Then don't write this one, just write these two. Fx equals this, fx equals, sorry, fx and gx are equal, write this. Same degree is clear. So the first condition is satisfied. And then write if fx equals gx, you can write this. So is there a possibility to switch the class to 5? Yeah, but the thing is like if there is a collision between a brain time, like if we do the class by from 7 to 9 throughout that time, if you have issue with the brain time, let me know. If there is a situation, like say that the praying time starts in between 7 and then finishes before 9, then you can't pray. So then I can just stop the class for like 5 to 10 minutes to allow you. But and I think there's no any proper way that we can check whether the students agree. No, like let's say if I ask the question now, some might say 5 is fine, some might say no, sir, 7 is good. It's not like to check a majority. No. But if you're having a problem like what I mentioned about the prayers problem, let me know. Okay, so then you can write these two. Okay, then good. Now look at the TU, the first question. The first question in the TU, find the constant such that the following relations are satisfied. Okay, now polynomials are equal. We are talking about the equality of polynomials. The equality of polynomials. Okay, first one in the TU. So I have uploaded the TU to the Telegram too, and probably the new students should have received polynomials tute and basic algebra tute. Okay, and the physical students even, they got the tute during the class, and for the newcomers in the online class, we have posted even those tutes, the previous tutes too. If you haven't received them, just check with the number that we have given. Even day before yesterday, I wrote it on the board. So just contact with him whether we have sent the tutes, or if let's say you couldn't drop a message mentioning that you are a newcomer, so send him a message, so he will be again sending the tutes. Okay. Okay, so the first one, 5x minus 1 is equal to, this is equal to a times x plus 1 plus b times x minus 1. Okay, so there are two ways. So there are two ways to find. Now we are supposed to find these AB constants. So there are two ways that you can do this. Okay, I'll explain in both ways. The first method is known as comparing coefficients. Comparing coefficients. Okay, so now it's clear. I'm going to compare the two coefficients, but here you can see the coefficient of x is 5. Here you can't see, like you properly can't see a coefficient of x2 because x can be seen in two places. So when x can be seen in two places, you can't properly say, okay, what is the coefficient of x? So then first you need to rearrange this. So if I rearrange this, ax plus a plus bx minus b. And now look at this, you can rearrange this. 5x minus 1 is equal to a plus b times x plus a minus b plus a minus b. Okay. So first thing, when you are comparing coefficients, you need to rearrange the polynomials such that you can clearly say what is the coefficient. And now I get x. What is the coefficient of x? It's a plus b here. It's equal to, so we get two equations. So if I take x, it's a plus b, which is equal to 5, the first equation. Then if you write the constant, you get a minus b is equal to minus 1. So you get two equations, simultaneous equations. Then you can solve this. Add these two, 1 plus 2, a plus b plus a minus b is equal to 5 minus 1. 2a is equal to 4. So a equals 2. And then after finding a, you can substitute and get the other answer. First one, a is 2, 2 plus b is equal to 5. B is equal to 3. So that's the first method, comparing coefficients. So what we do here is first then you need to rearrange the polynomials such that you can clearly see what is the coefficient of x, what is the coefficient of x squared, what is the constant, and then you equate the two coefficients. So this method is known as comparing coefficients and even equating coefficients. Both are same. Okay. Okay. Write in this way. Write in this way. Write in this way. When we have to find unknown terms, such that two polynomials are equal, such that two polynomials are equal, we can use two methods. I'll be explaining another, like I'll be doing another example so you can get the idea from that one. Yeah. Using two methods. The first method, comparing coefficients. First method, comparing coefficients within brackets, equating coefficients. Comparing coefficients within brackets, equating coefficients. Second one, number 2, substituting values. Number 2, substituting values. Substituting values. Okay. Okay, then put a dash inside two dash marks, write comparing coefficients. Write in this way, comparing coefficients. Don't underline, just using a red pen, write inside two dash marks, comparing coefficients. I'll be doing another question so you can understand this. For now, do this. I'll explain the second one too. Okay, comparing coefficients. Okay, then write it this way. In this method, in this method, we rearrange the polynomials. We rearrange the polynomials in a way. We rearrange the polynomials in a way. The coefficients can be clearly seen. The coefficients can be clearly seen. Coefficients can be clearly seen. And then we equate the corresponding coefficients. And then we equate the corresponding coefficients. We equate the corresponding coefficients. Corresponding coefficients. Okay. Then do this one and then do the second one too. Do this one and then do the second one too. Do this one and the second one. Let's finish the class. Yeah, somewhere around 9:15 maximum. Okay, so here, first rearrange this. 2x plus 3 I equals ax plus 2a plus bx minus 4b. So then you can say it's a plus bx plus 2a minus 4b. You might get fractions, that is fine. Nah? So then when you equate the x term, so here we have a plus b is equal to 2, that is the first one. And then if you consider the constant, you have 2a minus 4b is equal to 3. 2a minus 4b is equal to 3. And then it's a normal simultaneous equation simplification, which you have done even in O levels. So you can multiply the first one by 4, which gives you 4a plus 4b is equal to 8, and I'll take it as 1 dash. You can even name it as 3, that doesn't matter. So then add these two, because minus 4b plus 4b cancel off. Minus 4b plus 4b cancel off. 2a minus 4b plus 4a plus 4b is equal to 3 plus 8. So here then these two cancel off. We have 6a is equal to 11, giving you a equals 11 over 6. A equals 11 over 6. And then you can substitute that a here in the first one. From the first one, a is 11 over 6 plus b is equal to 2. So b is equal to 2 minus 11 over 6. 2 minus 11 over 6. So b is equal to 12 minus 11 over 6, which is equal to 1 over 6. Which is equal to 1 over 6. Clear? Which is equal to 1 over 6. Okay. So here the simplification part is a simultaneous equation simplification part. I hope you understood this one. It's based on simultaneous equation simplification. This one. This one, what happens is you just take out the brackets. So here when you take out the brackets, you can see common terms here. Ax and bx is common. So in this you can take x out, which gives you a plus b. And here you have the constant 2a minus 4b, which gives you the constant 2a minus 4b. So it's basically we are sending the x terms together, the constants together. Okay. 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 So this is the first method, comparing coefficients method. The comparing coefficients method. Okay, I'll give you one more question. Do question number 3, and everyone, when you first send me everyone answer who understood this. Send me a message. Understood. Everyone, I need everyone to respond who is following the exact line. And then do question number 3 too. Then let's move on to the next method. Hope you got this simplification thing that you were asking, because I don't think that the issue is here. The issue is probably here. So that's what I explained now. So I need everyone to send me a message, understood, and then do question number 3. Do question number 3. Everyone respond. You got it. No good. Okay, so then do question number 3. And when you complete it, send me a message. Done. Okay, I'll do question number 3 too. 6x minus 2 is equal to a times x plus 3, a times x plus 3 plus b times x minus 5. And then first rearrange this ax plus 3a bx minus 5b. So then we have a plus b x plus 3a minus 5b. 3a minus 5b. So this is equal to 6x minus 2, and then you equate the coefficients. From x you get a plus b is equal to 6, and from the constant you get 3a minus 5b is equal to minus 2, is equal to minus 2. Clear? Okay, so then you can multiply this by 5 or multiply this by 3. That is up to you. You can do the simplification in any way. If you multiply this by 5, it gives you 5a plus 5b is equal to, this is 30, then 30, which is 1 dash, and then you can add these two, the second one and the first one. When you add these two, you get 3a minus 5b plus 5a plus 5b, which is equal to minus 2 plus 30. Minus 2 plus 30. So these two cancel off, giving you 8a is equal to 28. So a is equal to 28 over, you can simplify. There are 2 4s and 7 4s, 7 over 2. And then when you substitute this in the first one, 7 over 2 plus b is equal to 6. So b is equal to 6 minus 7 over 2, which gives you b is equal to 12 minus 7 over 2. So b is equal to 5 over 2. B is equal to 5 over. Okay, b is equal to 5 over 2. So this is how you do this. Clear? B is equal to 5 over 2. Done. Good. Okay, now, so I can say, okay, good, I can see the correct answer. Let's move on to the next method. Write the next method in the same way that you wrote comparing coefficients inside two dash marks in a red pen. Write substitute in values. Right? Substitute in values. Substitute in values. The next method is substitute in values. Okay, so in this substitute in values method, the substitute in values method, what we do is, now we know this is equal to what? A times x plus 1 plus b times x minus 1. So here, like, we don't simplify this. We don't rearrange any of the polynomials. Okay. So is it okay to write 3 instead of... Yeah, that is a normal one. Like, you don't have to worry about what you put here. You can put 3 or any other number. I normally put 1 dash because we have taken this equation by multiplying the first one. So that is the only reason I have taken it. If not, you can put any number. Okay, so here what we do here is we substitute values in a way that we want to keep one constant and the remaining constant will be disappeared. So how can I make this one, like how can I make b disappeared? I'm making this factor which is attached with b 0. So that's why we say substitute in value. We substitute values, okay, we substitute values in a way that the factors are becoming 0. Okay, now here look at this. Look at this, what happens when I substitute x equals 1? Because I know to make this factor 0, you have to put x equals 1. So I'm putting x equals 1. And then I get, this is x equals 1. So 5 minus 1 is equal to 8 times 1 plus 1. For now I'm writing this, but then after I'll tell you, you don't have to write it because you don't have to write the parts that are becoming 0. No use, no need. When you can see it is becoming 0, you don't have to write it. A plus. So I'm just writing it to show this. In the first and second one, I'll write it, but then after I won't be writing. Okay, so then this becomes 0. This becomes 0. So then you have 4 equals 2a, a into 2, which means when you simplify, you get a equals to a equals to. So you have substituted x equals 1 to make this 0, and then you can substitute this x equals minus 1 to make this 0, because this factor becomes 0 when x equals minus 1. This becomes 0 when x equals minus 1. So when you substitute minus 1, every x should be substituted by minus 1. Here it's 5 times minus 1. A minus 1 is equal to minus 1 plus 1. For now, I'll just write it. A plus b times minus 1 minus 1. So now it is clear this becomes 0. For the first two questions, I'll be writing this. Then after, I won't write it. You have minus 5 minus 1, because 5 into minus 1 is minus 5, is equal to b into minus 2, which gives you b is equal to minus 6 over minus 2. So b is equal to 3. B is equal to 3, because minus 6 over minus 2 means b is equal to 3. So that is how you can do this. This becomes 0, and then you get b is equal to 3. Are we clear? Okay. So in the substituting values method, what you do, we substitute values for the variable in a way that some of the factors become 0. So one constant is remaining and the other constants cancel off or disappear. Okay. So we substitute values in a way such that some of the one of the constants are remaining and the other constants disappear. So cancel off. Okay. Okay. Right in this way, in this method, in this method, we substitute values for the variable we substitute values to the variable for the variable y in a way such that in a way one unknown term will be remaining, and the other unknown terms cancel off. Cancel off. Okay. Then do this one and then do the second one again in this method. Okay, do this one and do the second one. Okay, so let's do the second one. Two x plus 3, and this is equal to a times x plus 2, a times x plus 2 plus b times x minus 4. Okay, so here I told you we have to substitute values in a way that one unknown term is remaining, and if we have like more than two, the remaining unknown terms cancel off. So here you can make this 0 by substituting x equals 4. So I substitute x equals 4. So when it is 4, look at this, 2 into 4 plus 3 is equal to a times 4 plus 2. So I told you no need of writing this. When you see that that is 0, you don't have to write it. If you keep writing them, you have to write these big terms which become 0. So no need. Okay, you can see. So why did you substitute x equals 4? Because you wanted to make this factor 0. No? So then forget about it. So only simplify this. You get 8 plus 3 is equal to a into 6, which gives you a equals 11 over 6. That's all. And then to make this 0, you have to substitute x equals minus 2. To make this one 0, you have to substitute x equals minus 2. 2 times minus 2 plus 3 is equal to, this becomes 0, no need of writing it. B into minus 2 minus 4. So minus 4 plus 3 is equal to b into minus 6. So then I have b equals minus 1 over minus 6, which means b equals 1 over 6. Which means b equals 1 over 6. So b equals 1 over 6. So that is what you can do. Okay, can you send me a message you understood this method? And then let's move on to some different questions. Send me a message you understood this method. Send me a message you understood this method, and then let's move on to a different question. Okay, now look at question number 7. Good. Now look at question number 7. So let's finish this one. So like we don't have, then I don't have to even do this next week. Next week we can directly talk about the division algorithm of polynomials and long division method. We can talk about entirely about that one, about polynomial division, and we can have a start for the factor theorem, remainder theorem. Good. Okay, so then look at this question number 7. Okay, question number 7. 7, no? Yeah. We have x squared plus 4x plus 2, x squared plus 4x plus 2 is equal to a times x plus 1 x plus 2, a times x plus 1 x plus 2, and then we have bx times, we have we have bx plus x plus bx times x plus 1 and cx times x plus 2. Okay, now look at this. Like we have three terms here. So now look at this. To keep, if you want to keep a and if you want to take out b, check what are the terms that are common in b and c. If you want to take out b and c while remaining a, look at the terms which are common in b and c. Now it's clear. You can see this x is common. So how can we make x 0? We have to substitute x equals 0. Okay, how can we make x 0? We have to substitute x equals 0. So I substitute x equals 0. I substitute x equals 0. So this is 0. Even this is 0. So 2. A times 0 plus 1 and 0 plus 2. And no need of writing these two. No need of writing these two because this becomes 0 and even this becomes 0. this becomes 0, and even this becomes 0. Okay, so no need of writing it. I'll just erase this because these are not 0 for any x value. So then no need of writing it. So if you write it, so that's why I told you here, if you want to write the terms that are becoming 0, in this case, you have to write two unnecessary terms. Don't do it. Okay. Now let's simplify. 2 is equal to a into 1 into 2, which gives you a equals 1. So you can easily find this. Okay, so a is done. And now let's say you want to find, let's say you want to find b. So if you want to find b, what are you supposed to do? Look at a term common in a and c. So you can see this x plus 2 is common. So how can you make x plus 2 0? To make x plus 2 0, you need to substitute x equals good minus 2. You need to substitute x equals minus 2. So when you substitute x equals minus 2, you get minus 2 squared plus 4 into minus 2 plus 2, 4 into minus 2 plus 2. So here this becomes 0, this becomes 0, and this is only remaining b times b into minus 2 into minus 2 plus 1. B into minus 2 into minus 2 plus 1. Okay. And then you get 4 minus 8 plus 2 is equal to, because this becomes 0 and this becomes 0, p into minus 2 into minus 1. So when you simplify this, how much do you get? 4 minus 2 is equal to a b into minus 2 into plus 1, minus 1 is plus 2. So here you get b equals 1, minus 1. You get b equals minus 1 because minus 2 into minus 1 is plus 2. And then to find c, you need to make these two 0. What is common? X plus 1 is common. So I substitute x equals 1. I'll substitute it here. So I substitute x equals 1. I substitute x equals 1. So when you substitute x equals, not 1, sorry, minus 1, you get minus 1 squared plus 4 into minus 1 plus 2 is equal to, this becomes 0 and this becomes 0. So only this is remaining. C times minus 1 minus 1 plus 2, you get 1 minus 4 plus 2, which is equal to c into minus 1 into plus 1, which is minus c. So here you have minus 1, no, 3 minus 1. Minus 1 is equal to minus c. So c is equal to plus 1. So that is how we do it. C is equal to plus 1. Clear? Got it? Got the idea? Good. Okay, so then do question number 7 and then even do question number. I'll tell you. Okay, after this, do question number 10. Okay, after this, do question number 10. In question number 10, there's a small thing that you need to correct. It's bx times, question number 10, huh? Question number 10, bx times x plus 1, x minus 2, and here it's c times x plus 1, x plus 2. So there's no any x here. So these are the two errors. Here it's x minus 2, not x minus 1. And this one, there is no any x, there's no any x. In the tut, it's cx into x plus 1, x plus 2. So here, okay, do question number 10 and like send me a message mentioning the ABC values. So everyone send me a message mentioning the ABC values here. Question number 10, write it properly. I have just changed the question a bit. Do question number 10 and send me the answers ABC. Okay, good. So let's say that we have the answer. Okay, so then I'll do Question number 10 is what I asked you to do. Question number 10, we have x cube minus 3x squared, sorry, minus 3x plus 1, which is equal to ax into x minus 1 and x plus 2, and then bx x plus 1 x minus 2. So I told you to make this x minus 2 and no any cx, it's just c times x plus 1 x plus 2. So then to find a, check how can you make b and c disappear. So what is the common one? X plus 1 is common, so I'm substituting x equals minus 1. So when you substitute x equals minus 1, it's minus 1 cube minus 3 into minus 1 plus 1. So this is 0. This is 0. So these two are 0. And here a minus 1, minus 1, minus 1, minus 1 plus 2. So minus 1 plus 3 plus 1 is equal to a into minus 1 into minus 2 into plus 1. Which gives you these two cancel off, it's 3. So it's clear minus minus gives you plus a into 2. So what is a? A is equal to 3 over 2. A is equal to 3 over 2. Okay. Okay, then now look at this. So that's why I told you, if you keep writing now, let's say, it's clear this is 0. But let's say you keep writing them. Even knowing that it becomes 0, you just keep writing them. And then what happens? Okay, then what happens? You have to just write unnecessary terms. That is a waste of your time. So I only write the term what is remaining. Then x equals to find b, check what is common here. X plus 2 is common. To make x plus 2 0, I substitute x equals minus 2. Minus 2 cube minus 3 into minus 2 plus 1 is equal to this is 0. This is 0, only this is remaining. B times minus 2 plus 1 minus 2 is equal to minus 8 plus 6 plus 1 is equal to b minus 2 minus 1 and minus 4. Okay. So this is minus 1. So in this case, like you don't have to multiply this one like a grade 10 student. Minus 2 into minus 1 is plus 2. Plus 2 into minus 4 is minus 8. No needed. We don't do that in that way. You know when you have 3 minus, it's anyways minus. Like you don't have to multiply this one as a grade 10 student. Like how did you do it? Minus 2 into minus 1 is plus 2. Sorry, plus 2. Plus 2 into minus 4 is minus 8. No, don't do that in that way. You can just say minus, like we have 3 minus. So 3 minus means anyways it's minus. And then 2 into 4 is 8. Minus 8. That's all. Clear? So b is equal to minus 1 over minus 8, which is equal to b equals 1 over 8. Clear? B equals 1 over 8. So from here onwards, don't keep repeating in that way. Minus 2 into minus 1 is plus 2. Plus 2, no. If you have, like, let's say you have 5 numbers to multiply, then you can't be telling minus into minus is plus. No. When you have 5 minus marks, we know it is minus. Odd number of minus is minus. Even number of minus is plus. Okay, last one, to find C, what is common here, x is C. So you put x equals 0. You put x equals 0. So when you put 0, it's 0 plus 1 is equal to, so these two become 0. C into 0 plus 1, 0 plus 2. So 1 equals C into 1 into 2, so C is equal to half. So this is how you find this. So especially this comparing values method, substituting values method is easier when you have these, like when you have, like let's say 3-4 factors. I admit in the first, second and third one, even comparing coefficients is quite easy. But let's say if you have to simplify this, when you have to rearrange this, you have to simplify this, and then tell in the coefficient of this is this, the coefficient of this is this, then you have more work. So that is not how we do this. Are we clear? Okay, good. Okay, then look at this one. I'll just do a different question. I'll do like 2 more questions and finish because there's one more thing I need to explain. Look at this question number 4. I'll explain it from here and then I'll move on to question number 5. Look at this one, question number 4. Just write it and then see what you can do here. Look at question number 4. I'll just do 2 more questions and then we're done. Okay, in here, now it's clear. Question number 4. 2x squared plus 3x minus 5 is equal to a times x minus 1 x plus 1 b times x minus 1. Now you can see in this case, now look at this, you can see you can substitute x equals minus 1 to make this 0. So first do that. I substitute x equals minus 1. So when you substitute x equals minus 1, you get 2 into minus 1 squared plus 3 into minus 1. Minus 5 is equal to, this becomes 0, only that is remaining, b times minus 1 minus 1. So this is 2 minus 3 minus 5 is equal to b into minus 2. So you can divide and get the answer. B is equal to minus 6. You get minus 6. No, yeah, minus 6 over minus 2, which is 3. But the thing here, now look at this thing here. You can't find the other coefficient. You can't find not the coefficient, the other constant. Because let's say you substitute x equals 1. So no use of substituting x equals 1 because even this becomes 0 and this becomes 0. So when you put x equals 1, when you put x equals 1, this side becomes 0. So basically you get 0 equals 0. So then you are in a problem that you can't think of substituting another value to find this a. So in those instances, like we can use both them collectively. So what did I do? Like here, I have substituted a value, which means I'm using the substituting value method. And then you can use this comparing coefficient or equating coefficient. Now look at this. You don't have to expand. It's clear. What is the only place you get x squared term here? You get x squared term when you multiply these two. So from here, you don't get x squared. The only place that you get x squared when you multiply these two. So when you multiply these two, you get x squared. So what is the coefficient of x squared? That is a. What is the coefficient of x squared? That is a. So here, after doing this, I can compare the coefficient of x squared because I know the only place that I get x squared is this into this. So the coefficient is a. So then you have a equals, what is the coefficient of x here? X squared here, it's 2. Okay, so after substituting values, if you see that there are no any other values to find such a constant, you have to think in terms of comparing coefficients. Okay, you have to think in terms of comparing coefficients in this case. So here, for that purpose, you don't have to expand. You don't have to expand all and see. You can just say, okay, what is the coefficient of x squared? We have x. This is the only place I get x squared. So here the coefficient is a. So a is equal to this. Okay. Okay, put a red star mark and write in a normal pen. Put a red star mark and write in a normal pen. Write in a normal pen. Write it this way, write in a normal pen. To find unknown terms, no, wait. In the, like writing this, in these type of problems, in these types of problems, in these type of problems, we can use both the above mentioned methods. We can use both the above mentioned methods. Both the above mentioned methods. Okay. Okay, so do this one and then give a try to question number 5. Do this one and give a try to question number 5. Question number 5. And then let's finish with this one. Okay, so I'll explain this one, question number 5. Question number 5, 6x squared plus 10x. So you get this is equal to a times x minus 1, x plus 2, and then b times x plus 1. Is it x plus 2? X minus 2. X minus 2, and then c times x plus 1, x plus 2. Okay, so what did I mention? That there might be some instances where you have to use both the methods. Okay, so here now look at this. When you look at these two, you can see x plus 1 is common. So you substitute x equals minus 1. So when it is x equals minus 1, it's c into minus 1 square plus 10 into minus 1. So both these become 0. Here it's a times minus 1 and minus 1 plus 2. So this is 6 minus 10 is equal to a into minus 2 into plus 1. So this is minus 4 equals a into minus 2. So you get a equals minus 4 over minus 2, a equals 2. Sorry. Okay. Okay. So then The next one is, now look at what is common here. In these two, you can see x plus 2 is common. Here, x plus 2 is common. So I substitute x equals minus 2. So when you substitute x equals minus 2, so these are normal things you can do. 6 into minus 2 squared plus 10 into minus 2 10 into minus 2 is equal to, then this becomes 0, c becomes, c cancel off, b times minus 2 plus 1 and minus 2 minus 2. So then 6 into 4 minus 20 is equal to b into minus 1 minus 4, which is 4. So this gives you 24 minus 20 is equal to b into 4. So you have b equals 4 over 4. So it's 1. So you can find these two values by substituting values. You can find these two. And now the thing is about finding c, because to find c, you need to make these two 0. But when you look at these two, it's clear. When you look at these two, it's clear. None of the factors are the same. None of the factors are the same. None of the factors are the same. That means there won't be a value that you can substitute to make these two 0. And then I'm turning to comparing coefficients, because I can see there is no any value. Okay, there is no any value such that A and B both disappear at the same time. So I'm moving on to comparing coefficients. So I told you, you don't have to simplify this. Look at the places where you get x squared. You get x squared when these two, when you multiply these two, when you multiply these two, and when you multiply these two, you can find x squared. How can you find x squared? By multiplying these two, and these two. So from here, what is the coefficient of x squared? It's a. From here, what is the coefficient of x squared? It's b. From here, what is the coefficient of x squared? It's c. So then altogether, what is the coefficient of x squared? We have a, b, and c. So a plus b plus c is the coefficient of x squared. So that is how we can find the coefficient of x squared. Clear? So here, when you multiply these two, you get x squared. When you multiply these two, you get x squared. These two, you get x squared. So then the coefficient is a plus b plus c is equal to what? The coefficient of x squared here is 6. And this is equal to 6. So then you have a equals 2 plus b equals 1 plus c equals 6. So c equals 6 minus 3. So you get c is equal to 3. You get c is equal to 3. So that is how you can do this. Clear? So that is how you can do this. So after substituting values, because we have to understand by now, the easier method is substituting values, because you don't have to rearrange this and find the coefficient of this, and this. You can just keep substituting values and most of the terms become 0. But the thing is, if you realize, like in this case, you can't take out these two by substituting the same value. You have to turn into comparing coefficients. But even in that method, don't simplify this, don't expand this, because I told you, you can easily find what is x squared, the coefficient of x squared here. You only get x squared by these two. When you multiply these two, so the coefficient is a. Here you only get x squared when you multiply these two. So the coefficient is b. That is c. And then you can find the third one. C. Clear? Okay, so from that point, we'll finish our stuff for today. So you can do the remaining questions under question number 1. So next week, we'll be mainly focusing on, the division of polynomials. So longer division method those will be explained next week. Okay, so send me a message mentioning you understood what we have done today. So I told you this cover up classes mainly we have to do modulus functions and modulus functions, and then we have to do this one, polynomial functions. So we will be taking around 2.5 months to complete these lessons. In the meantime, you can do these partial fractions. I'll ask the admin to even put partial fractions, upload the partial fractions recording if we haven't done it. And from trigonometry onwards, because this is mainly for the newcomers who join the class, from trigonometry onwards, you have to continue with the normal theory class. Okay, we are done for today. Stay safe at home.